Welcome to qnawire.
So we want to find the gravitational force from Earth on a 75 kilogram astronaut who is 600 kilometers above the surface of the Earth. So we just say that the force from gravity is the gravitational constant times the mass of the Earth times the mass of the astronaut, and then divided by the distance here. So um, our distance, remember, we have to include the center of the Earth, or the radius of the Earth here. So it's going to be radius of the Earth plus the 600 kilometers above the surface they are. And we'll go ahead and convert that to meters. So 600 kilometers and then times 1,000, so 3 more zeros. And that's squared. And so now we'll look up our value for radius of the Earth and our mass of the Earth, and we can evaluate this. And we get that this force is 610 newtons on the astronaut. Then they want us to compare this to what the value on Earth would be. So we could do the same thing using just the radius of Earth, but we also know from kinematics that the force of gravity on the Earth is just the mass of the astronaut times gravitational acceleration, so 9.8. And so we can evaluate that, and we get that it's 735 newtons. So 610 is less than that, but not that much less. So we really can't say that the gravitational force is negligible in space at all. So the reason that we say then that astronauts are weightless is not because the force is small, but because everything is experiencing the same gravitational acceleration up there. So on Earth, the Earth doesn't accelerate relative to you, you accelerate to it. In space, though, the satellites that they're repairing is also having the same acceleration. So everything is moving together and has no apparent acceleration.